Hello everyone. Today in this video we will discuss about motion of connected bodies. Actually there are three types in the motion of the connected bodies. Now we will see the first type, that is motion of two bodies which are hanging free. Now everyone observe this diagram. Here let us consider two bodies of masses m1 and m2, the two which are attached to two ends of a string, and here m1 mass is greater than m2 mass. So m1 mass body will move in the downward direction with some acceleration a, and as this is moving in the downward direction and these two masses bodies are in the connected system, this m2 mass body will move in the upward direction with the same acceleration, and tension on both the sides will be same. Now let us consider one more thing. Consider m1 mass body as the A body and m2 mass body as the B body. Now we need to apply the Newton's second law for the A body and for the B body individually, and we need to calculate the tension formula and acceleration formula. And one more thing, as the A body is moving in the downward direction, that is nothing but motion is in the downward direction, so it will have the negative acceleration, and B body is moving in the upward direction, that is nothing but motion is in the upward direction, so B body will have the positive acceleration. So according to the positive acceleration for the B body and the negative acceleration for the A body, we need to apply the Newton's second law, and we need to calculate the values for T and acceleration, tensional force and acceleration. Now let us see for the first body, A body. Now one more thing, here motion is along the vertical direction, so we need to consider the vertical forces for the A body and for the B body. So here how many vertical forces are acting on the A body, m1 mass body? Only two forces are there. One force which is acting in the upward direction, so plus sign for the T force, and W1 is acting in the downward direction, so minus sign for the W1. So here F is equal to minus ma, as it is moving in the downward direction, you will get the minus acceleration. So minus ma, here in place of the F you will get total combined force along the vertical direction, that is T minus W1. So T minus W1 is equal to minus M1A. Now simplify this equation and get one equation in terms of acceleration. So you will get the acceleration in this way. So make it as the first equation. Now do the same procedure for the second body, B body. Here F is equal to M2A. And here again how many forces are there? Two forces are there which are acting in the vertical direction. Again plus sign for the T force, W2 sign convention is minus sign, and acceleration is positive acceleration. So for the B body, again F is equal to ma plus ma, T minus W2 is equal to plus M2A. Again simplify this equation and get one equation in terms of the acceleration. So make it as the second equation. Now we know that as these two bodies are connected to the same string, acceleration will be same for the A body and for the B body. So here from the consideration of the A body, you got one equation in terms of the acceleration. That acceleration will be equal to the acceleration which is coming from the consideration of the B body. So equate first equation with the second equation. You will get the tension formula from the simple calculation. Then substitute the tension formula, tension equation, third equation, either in the first equation acceleration equation or either in the second equation acceleration equation. You will get the acceleration formula. Once again see the procedure. This is the first type in the motion of the connected bodies, when two bodies are hanging free. As this is moving in the downward direction, you will have the negative acceleration, and B body is moving in the upward direction, so you will have the positive acceleration. So based on the motion consideration, you need to apply the Newton's second law. For the A body, you will get one equation in terms of acceleration. Next, do the same procedure for the B body. You will get one more equation in terms of acceleration. Equate first equation with the second equation. You will get the tension formula. Now substitute the tension formula either in the first equation or second equation. You will get the acceleration formula. So this is the tension formula. This is the acceleration formula. Now we will see the second type. Again in the second type of the connected bodies, again two types are there. First type is one body one body lying on the smooth horizontal plane and other is hanging free. Second type is one body lying on the rough horizontal plane and other is hanging free. Now what is the difference between these two types? Here smooth horizontal plane is there. That is nothing but in the free body diagrams of the A body and B body, you will not get any frictional resistance force as it is belonging to the smooth horizontal plane. As it is belonging to the rough horizontal plane, here in the free body diagrams for the A body and for the B body, you will get the frictional resistance force according to the main diagram. That is the difference between the first type and second type in the second type of the connected bodies. Now we will see the first type in the second type of the connected bodies. That is one body is lying on the smooth horizontal plane and other is hanging free. First of all, we will draw the free body diagrams for the A body and for the B body. See here, first we will see for the A body. And here again M1 mass is greater than M2 mass. So A body will move in the downward direction with the negative acceleration. Here again W1 is acting in the downward direction, tensional force is acting in the upward direction. This diagram you will get the same diagram as in the first diagram only. As in the first type of the connected bodies. Now this is the diagram for the B body. Here one more thing. Here when it is moving in the downward direction, A body is moving in the downward direction. This B body is projecting towards the positive x-axis in the horizontal direction. So the motion is along the horizontal direction. So we need to consider the horizontal forces only in the Newton's second law, F is equal to ma. So here motion is along the horizontal axis with the positive acceleration as it is projecting towards the positive x-axis. Here tension force, only one tensional force is there, that is also directing towards the positive x-axis only. So this is the diagram for the B body. Now apply the Newton's second law for the A body individually and for the B body individually to calculate the tension formula and acceleration formula. So here consider A body first of all. F is equal to minus ma. As it is moving in the downward direction, you will get the minus sign for the acceleration. So here for the A body, motion is along the vertical direction. So you need to consider the vertical forces only. That is nothing but T minus W1 is equal to ma. So simplify that equation. You will get one equation. Let it be first equation. Next consider B body. Here motion is along the horizontal axis. So you need to consider the horizontal forces. Here only one horizontal force is there. That is nothing but tensional force. So that is a T. So plus T. So here F is equal to plus ma. In place of F you will get only one horizontal force, that is nothing but T. So T is equal to M2A. Now make it as the second equation. Now everyone observe the first equation and the second equation. We can substitute the second equation in the first equation. You will get the acceleration formula. Now substitute the acceleration formula, third equation, in the second equation. You will get the tensional formula, tensional force formula. Once again see the procedure. This is the main diagram. From this main diagram, here A body individual free body diagram and B body individually free body diagram. From these two diagrams, from the motion consideration and from the Newton's second law, we will get the two equations. From the two equations, you will get the acceleration formula and tensional force formula. Next, second type in the second type of the connected bodies. That is nothing but one body lying on the rough horizontal plane and other is hanging. Everything will be same. Only one difference will be there. That is nothing but as it comes under the rough horizontal plane, here you will get the frictional resistance force in the opposite direction of the application of the force. Here as the A body is moving in the downward direction, B body will move in this direction. That is nothing but towards the positive x-axis. So motion is along the horizontal, positive horizontal axis. So frictional resistance force acts in the opposite direction of the motion of the B body. So here in this direction you will get the frictional resistance force. So we need to draw the free body diagrams for the A body and for the B body individually. You will get the same diagram for the A body. So here, as it is moving in the downward direction, A body, you will get the negative acceleration for the A body. And here one tensional force is acting in the upward direction and W1 force is acting in the downward direction. So this is the free body diagram for the A body. Now everyone observe the B body free body diagram. Here, as this is moving in the downward direction, here tensional force is acting towards the positive x direction. That is nothing but motion is along the positive x direction. So motion is along the positive x direction with the positive acceleration. So tension is towards the positive x axis. Motion, frictional resistance force always opposes to each other. So frictional resistance force is directing towards the negative x axis. Next here, whenever you get the frictional resistance force, you will get the formula for the frictional resistance force, that is F is equal to mu r. We need the r value to calculate the t value and a value. And one more thing, when you draw the free body diagram, you need to eliminate the supports. Here rough horizontal plane is there. So here this plane is acting on this body in the upward direction. So here you will get R2. Here you will get the weight W2 which is acting in the downward direction. One more thing, here also for the free body diagram for the B body, you will get R2 and W2. But we will not use the R2 value and W2 value in place of the F value. Why? Because here for the B body, motion is along the horizontal direction. So we need to consider the horizontal forces. R2 and W2 are vertical forces. So no need of the vertical forces in the free body diagram for this type. But here in this free body diagram, here FF force is there, frictional resistance force. So to calculate the FF force, we need the R2 value. So for that purpose, in the free body diagram, we are drawing, we are getting R2 value as well as W2 value. So this is the free body diagrams. These are the free body diagrams for the B body and for the A body. Now do the same procedure for the A body and for the B body by applying the Newton's second law. First of all, we will see for the A body. For the A body, F is equal to ma. As here motion is along the vertical direction, you need to consider the vertical forces. So here T and W1. So T minus W1 is equal to minus m1a. Now simplify this equation in terms of the acceleration. Next, consider the Newton's second law for the B body also. F is equal to plus m2a. Now here motion is along the horizontal direction. So we need to consider the horizontal forces. That is nothing but T minus FF. T minus FF is equal to m2a. Again FF formula is mu r. Mu r2 as it belongs to the second mass body m2. So mu r2. And we know that according to the equilibrium conditions, second equilibrium condition, sigma h is equal to 0. That is nothing but positive vertical components minus vertical components is equal to 0. That is nothing but positive vertical components is equal to negative vertical components. That is nothing but R2 is equal to W2. So here in place of the R2, we will get W2. So T minus mu W2 is equal to M2A. Now again make this, simplify this equation in terms of the A only. So from the A body, you are getting one equation in terms of acceleration. Again from the B body, you are getting one equation again in terms of the acceleration only. So now we know that accelerations for the A body and for the B body are equal. So equate first equation with the second equation. You will get the tension formula. Again substitute the tensional force formula either in the first equation or either in the second equation. You will get the acceleration formula. So once again see the procedure. These are the free body diagrams. Next, according to the consideration of the motions and in Newton's second law, first of all we are getting the tensional force formula, and by substituting that t value in the first or second equation, you will get the acceleration formula. See the second type once again. In the second type of the connected bodies, again two types are there. First type is smooth horizontal plane. These are the free body diagrams. This is the procedure. Second type is rough horizontal plane. So these are the free body diagrams. This is the procedure. Now last third type is, again in the third type of the connected bodies, again two types are there. Here one body lying on the smooth inclined plane and other is hanging free. Second type is rough horizontal plane. So do the same procedure. First of all, draw the free body diagrams. From the free body diagram, so once again, here again m1 mass is greater than m2 mass. So m1 mass will move in the downward direction with the negative acceleration. So here motion is along the vertical direction. So you need to consider the vertical forces in the Newton's second law. So here T and W1 are the vertical forces with the negative acceleration for the A body free body diagram. Now we will see the free body diagram for the B body. As here this A body is moving in the downward direction, and as both are in the connected system, this B body will move in the upward direction along the inclined plane. So here motion is along the inclined plane and it is moving in the upward direction with the positive acceleration. So tensional force is along the inclined plane and it is acting in the upward direction. Next, one more thing, here body is along the inclined plane. So here W2 will come under the inclined forces only. So we need to resolve it. So here alpha is equal to here alpha. So we need the forces along which are acting along the inclined plane. So here alpha is adjacent to the vertical axis here. So here you will get the cos alpha, here you will get the sin alpha. So along the inclined plane, here you will get one more force, that is nothing but W sin alpha. So here how many forces are there which are acting along the inclined plane? Two forces are there. That is nothing but a T force which is acting in the upward direction and W2 sin alpha which is acting in the downward direction. So we need to consider these two forces as motion and body are along the inclined plane. So we need to consider the forces which are acting along the inclined plane in place of the F in the Newton's second law. So by now everyone see here, for the A body, motion is along the vertical direction, we need to consider the vertical forces. So T minus W1. So T minus W1 is equal to minus M1A. Simplify that equation, you will get the formula in terms of acceleration. Make it as the first equation. Again for the B body, here F is equal to plus MA. Here how many forces are there which are acting along the inclined plane? Two forces are there. So here T minus W2 sin alpha. T minus W2 sin alpha. So again simplify that equation in terms of the acceleration. Now equate the first equation with the second equation, as both the masses bodies will have the same acceleration. You will get the tensional force formula. Again substitute the tensional force formula either in the first equation or in the second equation. You will get the acceleration formula. So this is the first type in the third type of the connected bodies. Free body diagrams and procedure. Now coming to the last type in the third type, that is second type, rough inclined plane. So only one difference will be there in the free body diagram of the B body, that is nothing but here you will get the frictional resistance force which is acting in the downward direction, and one more thing which is acting along the inclined plane. So in the free body diagram you will get the FF force, extra force. That is the only difference. Remaining free body diagrams, procedure, everything will be same, which is similar to this type only. Similar to the first type, smooth inclined plane in the C bit. So by simplifying you will get the accelerations in terms of the first equation and second equation. Equate the first equation with the second equation, as accelerations for the A body and for the B body are equal. you will get the tensional force formula. Substitute the tensional force formula in the first equation or second equation as in the previous procedure. You will get the acceleration formula. So this is the third type, second type, free body diagrams and procedure. Once again see all the types. Here motion of the connected bodies. First type is two bodies are hanging free. Second type, again two types are there. One body lying on the smooth horizontal plane and other is hanging free. Second type is one body lying on the rough horizontal plane and other is hanging free. Last third type is, again two types are there. First type is one body lying on the smooth inclined plane and other is hanging free. Second type is one body lying on the rough inclined plane and other is hanging free. So these are the derivation parts to calculate the tensional force formula and acceleration formula. Now we will see one problem. Here find acceleration of the moving loads as shown in the figure. Everyone observe the figure here. So this diagram will come under the second type of the connected bodies only. That is nothing but one body lying on the horizontal plane and other is hanging free. So this problem will come under the second type. Again in the second type two types are there. Smooth horizontal plane and rough horizontal plane. So we need to identify the problem. So for that one we will see the data. Here take the mass of the P as 120 and Q as 80 and mu value between the surfaces of contact is 0.3. So here mu value is given. Mu is nothing but coefficient of the friction. So when mu value is given, that is nothing but this problem will come under the rough horizontal plane only. So this problem is belonging to second type of the connected bodies. That is nothing but this type. Here one body lying on the rough horizontal plane and other is hanging free. So in this type we know the formulas for the tensional force formula from the third equation and acceleration formula from the fourth equation. So we can use the direct formulas from the derivation part for this problem. So here T formula is this one and A formula is this one. So in the formulas M1 value, M2 value and G value and mu values are there. So M1 value, M2 value both are directly given in the question. That is nothing but 120 kgs and 80 kgs. And mu value is directly given in the question 0.3. So substitute all the values which are given in the question. So you will get the direct values from the formulas. Suppose for example if you don't remember the formulas, then you can solve the problem from the Newton's second law and from the free body diagrams for the P body individually and for the Q body individually. You can do according to the subject wise or according to the formula wise. You will get the same answer.